Hello again, class. So this is once again Mr. Tidwell. We are going to be talking today about Unit 1, Lesson 14 for nets and surface area. Okay, so nets and surface area is what we're going to be talking about. So one of the first things I like to do whenever we're talking about new terms is review some of the things we've talked about. The best way to do that is in our digital notebook. So one way we're going to get to that is here on the home page. Scroll up a little bit. Right here, digital notebook. Okay, so I'm going to scroll down just a little bit on the left side. I can see all the other terms that I've got. I'm going to keep going. All right, so surface areas and nets. So a net is a two-dimensional representation of a polyhedron. It can be cut out and folded to make a polyhedron. So as you can see right here, you have got your cube all assembled here, but if you unfolded it, cut it at the edges, it would make this net. So all this is doing is basically taking it and laying it flat. So now you can see all the different faces that you would see in this normal cube, okay? So surface area, when we talk about surface area, we're talking about the surface area in square units. It is the number of unit squares it takes to cover all of the surfaces of a three-dimensional figure without having any gaps or overlaps. We're going to talk more and more about that as we go, but here's just a really good way of seeing how you're going to do this. So what we're going to end up doing is solving for the area of each individual face and then adding it all together, okay? So that's just a recap of some of our terms. Also, a couple of the terms we're going to talk about today are prisms and pyramids. So we talked about this previously. A pyramid is a type of polyhedron with two parallel faces that are identical copies of each other called bases. So in the ends, those are your bases, and they're connected by rectangles. So the different type of prism depends on the base. Right here it says the base, so it depends on it. So this one, because you can see a triangle right here, this would be a triangular prism. This would be a rectangular prism or a cube, since this looks like it's all squares. And then you've got the various other shapes, like this one would be a pentagonal prism, okay? So it just depends on what the face is to be what type of prism it's called. And then of course you've got your pyramid, which just looks like the pyramids in Egypt. All right. I'm going to go back to Canvas. I'm going to do a quick example before we get started. All right, so here's another example of a net and a rectangular prism. So right here, this is a really great way to see the different faces. Now, when we're going to start solving for this, sometimes it's actually easiest to break them apart into different faces. So for example, you see how right here, where it looks gray, I could kind of outline that in blue if that makes it easier for me to think about, okay? Now, because it's a rectangular face, remember, they're identical. So these two faces are the exact same. That's also the two faces that are right here, okay? So if I wanted to solve for that particular face, I would see that, okay, here, my dimensions, so this one is 3, and up here, we can see that from up top that is 2. So my dimensions for this particular box are 3 and 2. So that would be length times width, area equals length times width, which is 2 times 3. Equals 6. So this particular face, the value is 6. Same thing with this one. The value for this one is 6 because they're identical. Okay? Now, I could go and look at this face. That face is this one right here. It's also the same as this face right here. So I would need to solve for that as well. Okay? Now I can see what the dimensions are of this, right? Right here it tells me that right in here, this edge is 2. That's the value for that one. And the value for this edge, I can see right here, is 6. So that'd be the same equation. Area equals length times width, which is 2 times 6, which is 12. So the area for this one is 12, and also this one is 12. Let me go ahead and draw that in, because I also solved for that face. Now we've got to solve for our last 2 faces. So I've got this face up front and the one that's in the back. Now this can get kind of tricky when you're trying to draw this, so that's up to you on how you want to do it. Okay? If tracing it out like this helps you, that's fine. If it makes it more complicated, then you're going to have to figure out a different way to do it. So we know our dimensions for this particular rectangle too. We've got our length and we've got our width. So once again, same formula. Area equals length times width, which would be 3 times 6, which would be 18. So this one is 18 and this one is 18. So now I have found the area of all of my faces. But to find the surface area, I need to add all of those faces together. Okay? So that means that I need to take the surface area. Let me change my color. So surface area in this case would be, I'm going to have my 2 6s, 6 plus 6, plus I've got 2 12s, so 12 plus 12, and then I've got my 2 18s, 18 plus 18. So we add all those together, 6 plus 6 plus 12 plus 12 plus 18 plus 18. That's going to give you 72. Okay? That is going to be your surface area, 74 cubic centimeters squared. Okay? So that's what we're dealing with when we are talking about surface area of a rectangular prism. I want to show you guys some other examples. This one is a triangular prism. Okay? Now, remember, what makes it a triangular prism is its faces. Okay? I've got a face here and a face over here that are triangles. Okay? You can see those would be the same ones. Oh, I hate it when that happens. Those would be the same ones that are here and here, okay? Those are the exact same parts of that triangular prism, and it's the fact that these are triangles that make this a triangular prism. Our net right here just flattens it out so you can see all the faces. And again, when you're solving this, if you need to trace these out to try and help keep things straight, give them different different colors, that's fine. So these 2 faces would have the same value, and then the one at the bottom, that one would have a different value. So I could give that one a different color outline if I needed to, okay? Excuse me. And then last but not least, we've got our pyramids. Now, you'll notice that I have two different types of pyramids here. This first pyramid is a triangular pyramid, okay? You can see that the bottom of it is a triangle down here. That would be the bottom triangle right there, okay? Because the bottom is a triangle, it is a triangular pyramid. And remember the difference between a pyramid and a prism. A pyramid always comes to this point at the top, okay? You see how in a rectangular prism, there's not that one point where all the sides come together, okay? See that in the other one, oops. See that one and this one as well, right? There's not that one point that they come up to. But in our pyramid, it comes up to that one point, okay? And the base determines the name. So this is a triangular prism because the base is a triangle. This one is a rectangular prism because the base in this one is a rectangle, okay? And you can see that with the net. See how our rectangle down here is at the bottom? So that would be your net for that one. So it's a rectangular pyramid. Rectangular pyramid because once again, it comes up to a point, okay? So we're gonna have to pay attention to the types of nets and what shapes they make, okay? All right, let's go to the assignment for today and we can do a quick example. So we're gonna go to today's module. Today's lesson is on the 21st. Assignment is nets and surface area. Okay, so this one, the first question says, name the polyhedron that can be found by this net. So I gave you guys several examples, so I don't want to go over that one. If you need to refer to your notes, you can. But I do want to help you guys solve for this part, which says find the surface area of each one. So we're just going to pick B and try and work out the surface area of this one real quick, okay? So for B, I need to figure out the area of these triangles first. So let's do that. Area of a triangle. If we don't remember our triangle formula, that is once again here in our digital notebook. Area of a triangle is base times height divided by 2. So I'm going to write that in. That's always a good first step. If you're using a formula, you write it. Area equals base times height divided by 2. So for this particular triangle, this is going to be my base. So 1, 2, 3, 4. So my base is 4. For a height, I'm going to go up here to make my right angle. So that means that it's 1, 2, 3, 4, because I have to have a perpendicular angle between my base and my height, or 90 degrees. So 4 times 4 is 16. 16 divided by 2 equals 8. So the area of this triangle is 8, which they're all identical, so that means that this one is 8, this one is 8, and this one is 8. And now I've got the area inside, so I need to find the area for my base. So for this rectangle right here, so the formula for area of a rectangle is area equals length times width. So my length is 1, 2, 3, 4, and my width is 1, 2, 3, 4. So area equals 4 times 4, which we already did that math. Area equals 16. So I'm almost done. So for the surface area, I have now found the area of each face. But for the surface area, I need to add it all together. So for surface area, that's going to be 8 plus 8 plus 8 plus 8. So I've got 1, 2, 3, 4 faces of triangles. Four faces of the triangle. And then I've got my last one, which is the one in the center, plus 16. So that would be 16 plus 8 plus 8 plus 8 plus 8, which that is going to give me 48 centimeters squared. Okay, so then you would do the same thing for the other two shapes. You would find the area for each individual face, each one of these faces, and then you would add all of your faces together to figure out the surface area. Okay, so I want you guys to take care of this assignment and then work on your cool down. Thank you guys.